Greetings, everyone. Today we're going to talk about similar figures. So if you're watching this because I'm absent today, make sure that you followed all of the classroom rules of putting your cell phone up, having your notes out ready to go, and make sure that as you watch this, you pause the video. So if you see you're going to have to write something down, my suggestion is to pause it, write it down, and then listen. Don't forget in your notes to make a left column so that we can make some notes off to the side as we revisit the topics. And just know that today is an extension of what we already did in class. We already worked on solving proportions, so we're going to keep solving proportions. So remember that proportion means a ratio. Oops, I was trying to use a white pen. There we go. A ratio equal to a ratio. So we're going to have an unknown, we're going to have a number, a number, a number, and we're going to have to cross multiply to solve that proportion. Oops, 4 times 3. Okay, so we'd end up with 5x equals 12 divided by 5. So we're doing all those same steps of solving we've been doing over and over and over again. Okay, the difference today is when you set up your proportion, it's going to be from some shapes. So let's talk about similarity. You don't have to write this down, but similar items or things or animals need to have qualities where there's more similarities than not. So if I'm comparing a monkey and a bear, obviously not similar. But if I'm comparing these two butterflies, they have many like traits. Their colors are the same, their wings are the same, their pattern's pretty much the same. But the difference is their size. And so that size is only one factor. So we are going to say that they're similar. These triangles are similar. They're the same shape. They have sort of these same side lengths that go together. I'd pair up those sides. I'd say that, oops, gosh, my pens aren't changing color here. Try again. These sides would be considered corresponding, and then we talk about these sides and how they all match up, right? And we've got similar angles here, like this angle looks similar to this angle. There's a lot of similarity. That's how we use that word. But not all shapes are similar. I can have angles and side lengths, but it doesn't mean they're similar. They have to have a lot of similar traits. Okay, so my suggestion would be to pause the video right now, write down the definition, and then press play again. Okay. So we have similar figures. Similar figures have exactly the same shape, but not the same size. Similar figures have exactly the same shape, but not necessarily the same size. So exactly the same shape, if you would underline that or highlight it. Also, highlighters or colors will be helpful. So maybe pause the video and get some colors out. Let's talk about corresponding. So I already used that word in one of the previous slides. So my suggestion is to pause this video and then write down the definition. So corresponding sides and angles for that matter of two figures are in the same relative position. Corresponding sides and angles of two figures are in the same relative position. Okay. So let's talk about what that means here for a second, put some context to it. If I have a long skinny triangle like that and then I have the same thing, just smaller, that means that this side is corresponding to this side. They would be in the same position because they're both next to this small angle and they're both next to this 90-degree angle here. Okay? So we're noticing all these relationships and corresponding. So if that would mean this short side is corresponding to this short side, which leaves only one option. This longest side corresponds to this longest side. All right, so please in your notes write EX1. For directions, all you need to do is write find X. Okay. Now, to draw these triangles, follow my lead with this. This would be the easiest, okay? I would start off by drawing a horizontal line and then a smaller horizontal line. Then, from that horizontal line, I draw a diagonal a little bit more than half. Do the same thing on the other one, same size angle, a little more than half the horizontal. And then it's easy just to connect the remaining side. All right, so now let's take a look. We want to relate the corresponding sides. So please use colors right now, okay? So pause if you need to go grab some colors. Let's talk about this bottom side. Let's color or highlight that side. Okay. I want you to color the corresponding side on the other triangle. That would be this one. Okay. Those two sides have a relationship. Let's grab a different color. This next longest side that we started with drawing corresponds to this side. Okay, we can tell by the relative position and the way they're laid out. And the third color, that means this side corresponds to this side. Okay. So that's what's new today. That's it. First of all, determining which sides pair up. Okay. So just like last lesson, we need to first set up a blank proportion. My suggestion is to always start with your unknown. So start with your letter. It's the easiest place to start. Now, my letter is a yellow side. So what value also goes with that X? The other yellow side. So these colors help us to know that 4.5 is also yellow. So that's why they go together. Okay. Now I have to continue with a pattern here. Notice I did small triangle over big triangle. I need to continue that pattern. So what's a value on the small triangle? Another value would be 4. Okay, so 4 is the orange side on the small triangle. What value is also orange? 6. So 6 is on the larger triangle and it's the orange side. So you can see how those colors are really helpful. Look at the pattern we created. Small triangle over big triangle, small triangle over big triangle. And then we have yellow sides together and orange sides together. All right, there we go. The proportion itself isn't new, setting it up a little bit is. But now let's solve. To solve, we're going to do what we did last lesson, which was cross multiply. So to cross multiply, I'm going to have 6 times x equal to 4.5 times 4. 6 times x is 6x. 4.5 times 4. If you need a calculator, please make sure to go grab one. So that would be 18. Okay. Then I'm solving for x. We're doing what we've been doing for months now. I need to divide both sides by 6, and I end up with x equals 3. Let's talk about that. Does that make sense? Well, it does, because if I say x equals 3, that makes sense. It's smaller than the other yellow side, and they relate to each other. All right. For example 2, please pause this video, jot down the 2 triangles. I know it's hard to kind of guess their shape, but most importantly is going to be the letters and the numbers. So pause and write those down, please. Alrighty. First thing I want you to do is to get some colors out. You really need some colors right now. Our goal is to first talk about the corresponding sides, okay? Now, to help us do that, you'll notice there's little markings on the angles. So with your color, if you would mark this angle with a color and make it curved, there was one line there. So let's do also one line here where the other one was. Okay. Now you'll notice the other angle has 2 markings. So let's try to carry that over. Let's get a different color. And I've got 1, 2 markings. And over here on C, I've got 1 and 2 markings. Okay. All right, let's grab another color. Okay. If those 2 angles relate, that means the third angle also relates. So the missing angle, let's do 1, 2, 3 with that color. 1, 2, 3 with that color. Okay. Alrighty. This is going to help us know which ones are corresponding. So with a color, pick a different one. My first goal is to find P. So I'm going to color the side that says P right here. Now, a little bit harder to tell which side it matches up with. Currently, look at the angles it connects. It connects my orange to my blue. Okay, so that means I got to go over here and connect my orange to my blue. See how those colors are helpful? Those 2 sides go together. They pair up. But I need more than 1 pair of sides. I need 2 pairs of sides. So let's take a look. One more color. Well, this side length here is side B. That's not helpful. I don't want to find B, and it's not a number. So I'm going to highlight this other side, the 10. I could probably use a number. Okay, color that. That one goes from my blue to my purple mark. Okay, so blue to purple would be this side. See how those pair up? So now I could color the third side, but I don't need to, so that's optional. But I have enough information to set up my proportion. So let's start with the letter I'm trying to find, which is P. P was part of my yellow side, okay? Which means my other yellow side on the big triangle was 6. 6 is my other yellow side. So currently I have a relationship where I'm going small triangle to big triangle. So let's keep that up. All right, small triangle. I highlighted 5 on the small triangle. I highlighted that in red. Well, which other side's red on the big triangle? That would be 10. So 10 is on the big triangle. Now we get to cross multiply. I have 10 times P, and I have 6 times 5. I have 10P equals 30. If I divide both sides by 10, remember if you need to draw your line, please do so, and P equals 3. So that makes sense. If I was to put a 3 here where P is, it's smaller. It makes sense. Notice the relationship is it's half the size of the other triangle. So P is 3. Okay, you don't have to write this definition down, but let's just talk about it. We have what's called indirect measurement. So we can use similar triangles and proportions to find lengths that we can't directly measure in the real world. So what I mean by that, if I wanted to measure the height of this building, I could do it, but it'd be kind of tough. But I could measure lengths on the ground way easier. And I could use shadows and indirect measurements to find the height of the building. So let's look at an example. Hey, I do want you to draw this example. Here's my expectation. Okay, you guys? Write EX3. Draw a tree. I don't care. You can do old school Christmas tree if you want. Okay? But draw a tree. Doesn't have to be fancy. Just make it a tree. And then over here, this guy, just make a stick figure, but make him smaller than the tree. Okay? You can make a little tree and a little stick figure. Easy enough. And then down here, this gray line, please draw this gray line. That's the shadow of the man. And this gray line here is the shadow of the tree. Okay? Now, if you need to pause this video to take care of this drawing, please do so. All right, let's look at our values. I currently have unknown feet, so I'm going to use X. I have 10 feet, I have 6 feet, and I have 2 feet for the shadow. We can use indirect measurements to find the height of the tree. Let's set up our proportion. First of all, I'm going to start with my unknown, which is the tree height. The tree height is X. Well, it corresponds to the man's height. The man's height is 6 feet. All right, let's talk about shadows. I have a shadow of 10 feet. Well, that connects with the tree, so I'm going to put it on top. So you'll notice my pattern here. I have anything to do with the tree up top, anything to do with the man on bottom. So the man's shadow is 2 feet. Hey, we have our proportion. Let's cross multiply. I have a 2 times an X equal to a 10 times a 6. I have a 2X and I have a 60. I divide both sides by 2. I have X equals and a 30. So my label, this has context to it. I would say 30 feet. And we would say the tree is 30 feet. And make sure it makes sense. A tree being 30 feet high makes sense. All right, let's take a look at our second to last example. You don't have to write this down. You're just going to talk it out with me. An architect created a scale model of what a college campus would look like once construction is finished. The scale for this model is 2 inches to 25 feet. Hey, anytime you see the word scale, that creates a ratio. I have 2 inches to 25 feet. So write that. I would write that down first on my homework. The tallest building in the model is 10 inches tall. How tall is the actual building? So now I need a proportion. The other value I have is 10 inches. Should that go on top or bottom? It should go on top because my inches are all on top and my feet are all on bottom. So that means I don't know how many feet tall the building is. So let's cross multiply. I have 2 times X. I have 25 times 10. That gets me to 2X equals 250. If I divide both sides by 2, I have 125. But I need a label. Anytime there's a context in the question, I need a context in my answer. I have 125 feet for the height of the actual building. And that makes sense. Okay, last example. Please write this in your notes. Okay, we have an A and a B triangle. We have a side length. The longest side, I'm going to highlight it yellow, is 3x plus 11. And this side is 42. Those are corresponding sides. I can tell by the way they look. But then I'm given this information that says the scale factor from A to B is 5 to 6. A to B is 5 to 6. So I know I'm going to do proportions for every single problem today. So I'm going to start off with this 5 to 6. 5 is smaller, so I'm going to say small to big. Or you'll notice it said A to B. So this is triangle A to triangle B. I have my scale 5 to 6. But what am I going to put on the top of this second ratio? Well, on the small triangle, I have this information of 3x plus 11. And the corresponding side on the big triangle is 42. Small triangle information's on top, big triangle information's on bottom. I have two ratios that I can now cross multiply. So let's take a look. I have 5 times 42 equals, now here's where in our notes last class I asked you to put parentheses around your expressions. You're going to have to continue doing that today. So I'm doing this example for that reason because that's often missed. So the second part of my cross multiplication is 6 times 3x plus 11. Okay. So I now need to simplify. I need to take care of 5 times 42. I don't have a calculator, so I'm just going to do that over here quick, which gets me to 210. Over here, I have a number outside of parentheses. I'm following my 4 steps, you guys. So first I need to distribute. 6 times 3x is 18x. 6 times 11 is 66. All right, I need to solve for x. So my next step would be PEMDAS backwards. I'm going to subtract 66 from both sides. Okay. So let's see, that'll give me to 200, 150, I think 144 if I'm correct. Okay. Last step, if I divide by 18, that would isolate my x. I would end up with x equals, I don't have a calculator again, but you guys do, so make sure you check my work, okay? Oh, darn, that's not going to be very helpful. Let's see, 18, 36, 30, okay, so it's probably going to be 9, I think, right? Check my work. X equals 9. All right, so that last example is very important. You might have to revisit this video or your notes when you take a look at our worksheet today. Okay, make sure you show all work. Okay, set up all those proportions. I'm going to say use those colors. All right, use those colors to show me the corresponding sides. That shows me you understand. Okay, and then of course, if it's real world, I need to see labels. All right, so we'll get started on our worksheet. If you have any questions, let me know, but get right to work and see you next time.